Hello everyone. Before we start the next lesson, I've got a warm-up question for you. So you'll see a nice graph here, income and expenses for first, second, third, and fourth quarter, and dollars in thousands. So I'd like you to look at the graph and estimate the revenue in the third quarter as well as the income in the second quarter. So remember, revenue is the actual amount of money made, it's not the same as income. So pause the video and try this question, and when you're done, you can check back in and continue watching the video to see how you did. So for this first one, revenue in the third quarter, I look at the third quarter. Well, looks like income was about $72,000 and expenses were about $80,000. So revenue would be the actual amount of money that you make, or in this case lose, because expenses are more than income. So the difference between expenses and income is $8,000. So revenue is actually negative $8,000. That's how we would read this. Now for part B, it says, what's the income in the second quarter? This one's a little easier. Income is just these bars in the second quarter. Looks like it's a little higher than the 100 line here. We'll say about $105,000. So this leads into our lesson on reading graphs. This is the first lesson in our new unit on data management and statistics. So for the rest of this week, we're looking at data management. It's how do you work with data, numbers, information. Part of that is displaying it in graph form and understanding what the graphs are telling you. So our learning goal for this lesson is by the end of it, you should be able to read what we call 1 and 2 variable graphs. So in this lesson, I'm going to talk about what 1 and 2 variables information, what that means, and also we'll look at how to graph those things. So here's my first example. I have a graph shown. It has marks out of 50 on the horizontal axis and frequency on the vertical axis. If you're not familiar with the word frequency, frequency just refers to the number of times something happens. So the way I would read this is there was one person with a mark between 0 and 10. There were 2 people with a mark between 10 and 20. There were 3 people with a mark between 20 and 30, etc. Okay? Now, this type of graph, a lot of people look at it and they say, this is a bar graph, but that would be wrong. Bar graphs are used for showing differences between different categories. However, these are all marks out of 50, and it's on a range from 0 to 50 and anything in between. So this is actually called a histogram. So let's practice reading a histogram. So for this example, what mark was the most common? Well, most common means the one that occurred the most often. So it's the highest bar. Well, that is here. So the mark that occurred most often, well, it wasn't 30, it wasn't 40. Remember, this is a range. It's between 30 and 40. We don't have an exact number. So the mark that occurred most often was between 30 and 40. So in part B, what are the lowest and highest marks that were recorded? Well, the lowest marks were between 0 and 10, and the highest marks were between 40 and 50. Now, some people get confused between bar graphs and histograms, and I kind of mentioned this earlier, but if you look at a bar graph, you usually have different categories, like this example here. So we've got different countries. These aren't numbers on a continuous scale. Whereas in a histogram, you have a number on a continuous scale. So we have, in this example, starting at 100, up to 350 and any value in between, but we just have bars for the different intervals in that whole range. Another important difference is that bar graphs have gaps between the bars because they're separate categories. There's no overlap. In a histogram, there's no gaps between the bars because they all belong on a continuous range. There's overlap between the numbers. So if there's gaps, that's a bar graph. If there's no gaps, that's a histogram. This next graph is one that you're probably familiar with. Most people call these a pie chart. You can also call it a circle graph. Either way, it's talking about the same thing. So for this example, I can ask, what was the favorite type of movie? Well, it's the biggest piece of the pie. Romance, of course. Now with pie charts, typically you are shown percentages. So here I can see the percentage of people who answered each category. 20% said sci-fi, 5% said drama, 30% romance, 25% action, 20% said comedy. But those are percentages of people who answered. It's not the number of people who said these things. It's the percentage of the people who said these things. So if you want to know the number of people who answered these things, you're going to have to do a calculation. So for example, if there were 312 people that were surveyed, how many people chose each type of movie? Okay, so if you want to calculate percent of a number, you have to multiply that percent as a decimal by the number. So if I want to know 30% of 312, my calculation is 0.3 times 312. And if I do that in my calculator, it says 93.6. However, remember, we're talking about number of people. How many people? So I can't say there were 93.6 people that answered romance. That doesn't make any sense. You have to have a whole number here. So I would round that up to 94. So I have 94 people said romance. Now what I would like you to do right now is pause the video so that you can take time to calculate how many people answered drama, sci-fi, comedy, and action. Use a similar calculation as I did here for the romance answer and see how you do. So pause the video, try all of these, and then when you're ready to check, you can unpause the video. So when you do the calculations, these are the numbers you should get. So we had 94 people for romance, 16 said drama, 62 said sci-fi, 62 said comedy, and 78 said action. Now I just wanted to show you this because some people, when it's something like 5%, some people will put 0.5, but it's 0.05. 0.5 would just be 50%, so you get a much larger number. So just be careful when it's a single digit percentage, you got to put that 0 after the decimal. So that's kind of how you can work with a pie chart. Now this next example, you've probably seen these types of graphs too, where you have all these different points plotted on an X and Y grid. This is called a scatter plot, because the points are scattered all over the plot, which is another word for graph. Now, when you read a scatter plot, you have to make sure you're looking at the axis titles. So here I have elevation in meters and mean annual temperature in Celsius. So remember, mean is just the average. So we can see there's a relationship between the annual temperature and the elevation. So elevation is just how high up you are from sea level. So when it says 500, that would be 500 meters above sea level. This is 1,000 meters above sea level. So the higher up you go in elevation, we can see the average annual temperature goes down. Overall, that's the general trend. But what does each point individually mean? So here's my first question. What does the circled point represent? So I'm talking about this point right here. What does it represent? Well, it looks like that point exists where the elevation is, well, it's over 1,000. If we look at the scale, I'm going to estimate about 1,050. When the elevation's of 1,050 meters, the annual temperature is, let's estimate 17 degrees Celsius. Another skill that's useful to have when dealing with scatter plots is to kind of look behind the graph and how did they get these different points? Like, how do they know to put a point here, a point here, a point here, or any of that? So you have to think, what did they probably do to get these points in order to make a graph? So my question, I guess I worded it this way, what might each dot represent? And so if I was in class, I'd take your comments here, but you can just try to think of how did they get these dots? One answer that I typically get is that these dots could be from different towns. So in a certain town, what's the elevation above sea level, and then record the annual temperature in that town, and then now you have a dot. And if you have a bunch of different towns with different elevations, you've recorded the annual temperature at each town, then you now have a bunch of different dots, and you can place each town's dot on this graph, and now you can look at all of them and see the trend. And so that brings us to the practice. So there's 4 practice questions on page 126 in your textbook, but the link is also given on Google Classroom for the work. If you have any questions, let me know so I can help.